Hey everyone, welcome. Today we're going to build something seriously cool. A simple but really powerful digital tripwire using a KY-10 sensor and an Arduino. I promise, by the end of this, you'll have a working motion detector that you can use in all kinds of awesome projects. So let's dive right in. So what is a digital tripwire really? Well, just imagine an invisible beam of light. As long as nothing crosses that beam, everything's cool. But the second something breaks it, boom, an alert gets triggered. That's the simple but brilliant idea behind this little sensor.
And this slide, it shows you everything you need to know. On the left, we've got state 1, signal clear. See that green check mark? That means the infrared beam is just zipping along totally uninterrupted. But then look at the right, state 2, signal interrupted. The moment an object gets in the way, that beam is broken, and that's our trigger. The sensor instantly flips its signal. This simple on or off logic, well, that's the heart of our entire project.
Okay, so we've got the how it works part down. Now let's get our hands dirty and meet the tools for the job, the key players that are going to bring our digital tripwire to life.
Here's the whole setup. On the left, you can see everything we're working with. The Arduino Uno, which is basically the brain of our operation, a few jumper wires, which you can think of as the nervous system, and of course the star of the show, the KY-10 sensor, which you can see up close on the right. This little guy is the eye of our project, just constantly watching for that break in the beam.
All right, time to actually put this thing together. And don't worry, this might look a little technical, but I promise you, it's incredibly straightforward. We only need to make 3 simple connections. That's it.
So before we start plugging things in, let's just take a quick look at what these 3 little pins on the KY-10 actually do. S is for signal. This is the one that yells at the Arduino when the beam is broken. The middle pin with the plus sign is for power. It needs 5 volts to do its job. And finally, the pin with the minus sign is ground, which just completes the whole electrical circuit.
Okay, let's get these wired up. First up, take a jumper wire and connect the signal pin, that's the S, all the way over to digital pin 10 on your Arduino. Step 2, connect that middle power pin right into the 5V port. And for the final step, connect the ground pin, the one with the minus sign, to any of the GND ports. See, just 3 wires.
And there you have it, the complete circuit. You can see those 3 connections we just made. Now listen up, because this next part is really important. It's the polarity check. Before you plug anything in, please double check that your middle pin goes to 5V and the minus pin goes to ground. If you get this backward, you could damage your gear, so that quick 5-second check is absolutely worth it.
Okay, our circuit is all wired up. We're almost there. Just one final piece to the puzzle. We need to give our Arduino a brain. Let's break down the code that makes this whole thing tick. So here's the entire program, or sketch, as they call it in the Arduino world. Now I know it might look like a lot at first glance, but don't worry about it. We're just going to zero in on the 2 lines that do all the real work here.
All right, let's tackle this first key line. Now this looks a little weird, right? We're telling an input pin to be high, but this is actually a really clever trick. This command turns on the Arduino's built-in pull-up resistor. Think of it like this. Without it, that input pin is just kind of floating. It's not on or off, so the Arduino gets confused. This line basically pulls the signal up to a solid on state by default. That way, we get a super clean, stable, and reliable reading every single time. It's a neat little hack.
And this is the magic moment. This is our trigger. The code is just sitting there in a loop, constantly asking one simple question over and over. Is the signal from the sensor high? Remember, when the beam is broken, the sensor sends that high signal. The very instant the Arduino sees that, bam, the condition is met, and it runs whatever command you've told it to. In our case, printing a message on the screen. Hardware wired? Check. Code uploaded? Check. And now, for my favorite part, let's see this thing in action and start dreaming up what you can do with it. And look at that, it works. This is the moment of truth. On the left, you see something physically breaking that infrared beam. And instantly, over on the right, the computer screen spits out signal detected. This is exactly what we wanted to see. The physical world directly talking to the digital world. Success!
So, now that you've built this thing, what can you actually do with it? Well, this is where the fun really begins. You could easily make a security alarm for a door or a window. Or you could put it over a little conveyor belt and have it count objects as they pass by. It's even used in high-tech stuff like 3D printers to tell the machine, hey, you've reached the end, stop moving. And that really brings us to the most important question of all. You now have the skill, you have the tool to build a digital tripwire, so the real question is, what are you going to create with it?
And that's pretty much it. You've officially mastered the digital tripwire.
Whether you want to secure your room, count your candy, or add some smarts to a machine, you now have the knowledge to make it happen. Have fun and happy building!
Hey everyone, today we're going to build something that's, super foundational but also incredibly cool, a simple detection system. We'll be using a KY-010-Light barrier sensor and an Arduino to create our very own digital tripwire. It's going to be awesome, so let's jump right in.
So, have you ever wondered how an automatic door knows you're there, or how a factory can count thousands of items on a conveyor belt without missing a beat? Well, a lot of the time, the secret is just a simple, invisible beam of light. And that's exactly what we're creating today, an invisible line that, when crossed, makes something happen. It's way more straightforward than you might think, and it all starts with this little component called a light barrier.
So what exactly is a light barrier? Okay, imagine you've got a tiny flashlight pointed directly at a tiny light sensor. As long as that sensor can see the light, everything's cool. It sends out a steady signal. But the very second something, your finger, a box, anything, gets in the way and breaks that beam, the signal gets cut off. It's this simple change, from on to off, that our Arduino can detect and use to react to the world.
All right, here's our game plan. First, we're going to get to know our key component, the KY-010 sensor. Then, we'll get our hands dirty and wire it up to the Arduino. It's super easy. After that, we'll dive into the code, which is basically the brains of the operation. Then comes the best part, seeing it all work. And finally, we'll brainstorm some really cool projects you can build with this new skill.
Okay, first things first, let's meet the star of our show, the KY-010 sensor. Think of this little module as a brand new set of eyes for your project, always watching for an interruption.
The KY-010 is what's called a photo-electro-phototensor, and it's awesome because it's both compact and super reliable. Its entire job, its whole purpose in life, is to do one thing really, really well: detect anything that passes through that little U-shaped slot. This simple design makes it a favorite for all kinds of detection and automation projects.
Now, this might just look like a couple of numbers, but it's actually a huge deal. The KY-010 can run on anything from 3.3 to 5 volts. Why does that matter? Because it means it's pretty much compatible with all the popular microcontroller boards out there. We're using a 5-volt Arduino today, but it would work just as well with a 3.3-volt board like a Raspberry Pi. That kind of flexibility makes this a fantastic little sensor to have in your toolbox. All right, let's get to the hardware. I promise connecting the KY-010 to your Arduino could not be simpler. We're literally just talking about 3 little wires. This chart lays it all out perfectly. The sensor's signal pin, that's the one that talks to the Arduino, connects to digital pin 10. Simple enough. Then you just need power. The pin labeled +V goes to the 5V pin on the Arduino, and the GND pin goes to ground. And that's it. Seriously, 3 connections and our hardware is good to go. Okay, our circuit is all wired up, but right now it's just a collection of parts. It's time to give it a brain. Let's dive into the Arduino code and see how we tell it what to do with the information from our sensor. The code follows a super logical 4-step process. First, we just tell the Arduino which pin we've connected the sensor to. Second, we configure that pin inside the setup function, which only runs once when you power it on. Third, we get into the main loop, where we'll just read the sensor's status over and over again. And finally, step 4, we tell the Arduino how to react when it sees a signal. So, let's zoom in on that setup function. 2 really important things are happening here. First, we set pin 10 as an input because the Arduino is receiving information from the sensor. Then, we activate something called the internal pull-up resistor. This is a crucial little trick. It basically makes sure the pin has a stable default signal so we don't get wacky, unreliable readings. And finally, serial.begin 9600. That just opens up a little communication line so we can see the results on our computer. And now we get to the main loop. This is the part of the code that just runs forever, over and over and over. And the heart of it is this one command, digital read barrier. You can think of this as the Arduino constantly asking the sensor, hey, you see anything? Is the beam broken? What's your status? It then takes that answer and gets ready to act. And this little if statement right here, this is where the magic happens. It takes the answer from the sensor and checks it. If the value is high, that's our trigger. That means the beam has been interrupted. When that happens, the Arduino immediately runs whatever command we've tucked inside that if block. So we've wired the circuit, we've written and uploaded the code, now it's time for the most satisfying part of any project, seeing it actually work. This is the payoff. And there it is.
All you have to do is open the serial monitor in the Arduino software, pass your finger right through the sensor slot, and the instant you break that beam, bam, signal detected pops up on your screen. It might be a simple message, but it's proof that our entire system, the hardware and the software, is working together perfectly.
Okay, so we have a working digital tripwire. That's awesome. But the real fun starts now. What can you actually do with this? Let's explore some of the possibilities.
I mean, this one simple sensor is the starting point for so many cool projects. You could build a basic security system for your room that beeps when the door is opened. Or how about an automated counter to track how many times your pet goes in and out? You could even use it to give a simple robot a basic pair of eyes, helping it detect obstacles. The possibilities are seriously huge.
So there you have it. In just a few minutes, we've taken a simple sensor and a few lines of code and turned them into a working detection system. We've seen how a basic on or off signal can become really useful information. The foundation is now yours to build on. So the only real question left is, what are you going to build first?